Hi everyone, welcome to this week's lecture, which is a summary lecture, a trip down memory lane of everything that we've been through this course. It sounds a bit dramatic if you phrase it like that, everything we've been through, everything we've experienced together. Don't know if that's any improvement, but look, hopefully it's a good reflection on all the things you've learned in this semester, and also, firstly, congratulations on getting to this point. Assuming you've watched all the lectures in sequential order, it's a big achievement. There's been a lot of different new statistical concepts that have been introduced, some old, some new, and then building on that through this course. There's a lot of content that you've had to wrap your heads around, and so hopefully this lecture sort of frames the links between each of the concepts from lecture to lecture, but also gives you a sense to reflect on, oh yeah, I learned that, I remember that. And if for any reason you say, actually, I forget what that means, or I don't really quite understand that concept, it's a good indicator to say, okay, well, that's the lecture I need to navigate back to. So summary and conclusions is really what today is all about, and a good way to wrap up this course as well. So what we've covered, the course has been structured in a way where the first two lectures focused on survey research and design. And then we built from there to look into univariate and bivariate descriptives and graphs. And you realize the passion that I have for descriptive statistics and descriptive graphing. We talked as well about psychometrics and multiple linear regression. These were really the two main pieces of advanced statistical analyses, which provided you with the tools that you need to be able to critically analyze research that use these sort of techniques, but also be able to conduct your own research. And then we built from there into power and effect sizes. But in saying that, even things in univariate, bivariate descriptives and graphs and survey research design, they're all really important conceptual foundations. And hopefully what you've learned from this course is you can't just walk in, conduct some statistics, and then walk away and say, okay, this is what we found. There is considered thinking that goes through at every single level, from the question you want to ask, to how you design your survey, to how you probe and investigate the data that you've collected through univariate or bivariate graphs and descriptives, and then building on that through the assumptions for testing the analyses, and then critically understanding and analyzing the results that come out as a function of your analyses, and building upon that with framing it. So really at every single step there's a considered thought process. And so hopefully this lecture has given you the sort of ingredients to be able to make your own analyses in that way. So, and what I mean by that is now you really have the tools to be able to say, I'm interested in this question. Well, let me work through the process from start to end of being able to address that question. And so this course hopefully gives you a good grounding in that. So for the trip down memory lane, we start with survey research. We talked about what is a survey, and I tried to hammer in the point that a survey is a standardized stimulus designed to convert fuzzy psychological phenomena into hard data. And I emphasized that the focus of it being a standardized stimulus was essential because we want to minimize error. And when we're talking about minimizing error, what we mean in this context is ensuring that what we see in our results is attributed to what we're observing in the population or in the target population, rather than being an artifact of the ways in which we ask our questions. And so we could ask the same question in many different ways, and if we were to do it in that way, that would lead to many different results. And so what's really important with a survey is that it's standardized. The same question is asked the same way to every participant, and then the responses we get reflect whatever we're measuring within that survey. So that was really the core of defining what is a survey and why it needs to be standardized, and how we're converting the idea of fuzzy psychological phenomena like, say, personality. What does that mean? We could actually use our understanding of survey research and design to measure it. And once it gets measured, it can be analyzed and it can be investigated further. And so we can convert that into hard data and then draw conclusions from that data. So why do we do research? It's really a deep question, but in the context of what we're doing here, it's to help us gather information or test and build theories. And I think research is an incredibly rewarding and fulfilling profession, largely because you have a lot of autonomy over the types of questions that you can answer. And so when you can design a question that you think is important to investigate and that you're curious to know what the answer is to, and maybe there's not the answer available in the literature, then that can sort of spur on this motivation of inquiry. And so it allows you to gather information in relation to that topic of interest, and then you start testing and building theories. On the point of testing and building theories, I know we discussed these points in some ways later on in the course in the ninth lecture of the series, but it's important in research and in science to be able to, in some ways, remove yourself from what you're looking at and try to look as objective as possible. And what I mean by that is when you're trying to test and build theories, try not to attach your own identity to the testing and building of a theory. And it can be challenging. I think in science, many times you work on an idea that you think is good, that you think has backing from the literature, and then you test it and maybe your data doesn't show what you had thought it would show. But more often than not, if you follow the impulse of, okay, if I've done all the steps right and I've worked through the process as rigorously as I can, and here's the data, if we were to trust this data, where does that question then take us? And if we were to change our thinking, where does that thinking then take us? That leads you to often at times very new and interesting ideas that are undiscovered, rather than pillowing down a path because it's formed and shaped a part of your identity. I say this because it's seen widely in science, and in part it's what drew me to the topic that I did in my early research, which was focusing on the contribution of menopause to brain health. It's a very important topic. Women have higher rates of dementia than men, and in part this is accounted for by the fact that women live longer, but it's not fully accounted for by that. And so I was interested to know what factors could contribute and what are the changes occurring at different stages of the female lifespan. And so I focused the early parts of my research on menopause. What are the changes around menopause? How do these changes, how are they associated with changes in brain health? And so it's an important question. It was an interesting question, but also it was a question that I felt I had zero or very little skin in the game for. I'm not a woman. I won't experience menopause. And I felt like it was a question that allowed me to think a bit more objectively and not feel too tied to a certain ideology. That's not always the case, and that's not necessarily how you should conduct research, but I certainly had the foresight in the early part of my career to try to be aware of this pool of testing and building theories. So I just want to raise that now as well in the context of what you know in science and how you progress in your careers, regardless of whether you go down a clinical path, a science path, another path, policy development, any other data analyst. The skills that you've learned in this course of critical thinking will apply across sectors. So this idea of testing and building theories, we all have ideas that we're generating, we're all testing them. I guess the point is coming back to the question of what if what I'm looking at is not in the ways that it may seem. And I think the greatest scientists were always trying to find evidence against their theories rather than trying to support it. And so the pros and cons of survey research, we talked about the pros being ecological validity, that I could assess you in your own environments and see what your responses are. So you're not coming into a lab and you're conducting an experiment within a lab-based setting, and so it may not translate to the real world. And so surveys are ecologically valid tools, and you can administer them via email or even postal vote. So it's you can access people wherever they are through these mechanisms. So it's a really powerful tool for enhancing or maximizing ecological validity. And it's very cost efficient, not in the postal side of collecting data as much as it is in terms of you could start designing a survey, generate it online, and send a link out to whomever you're looking for very quickly and with very little cost associated with it. So there's a cost efficiency gain, and you can obtain lots and lots of data. And as we learned through our process of the two main pieces of multiple linear regression and factor analysis, having lots of data is really useful for these kinds of tools. And also you can see how the progression of survey research and our ability to do these types of analyses has built in parallel with our ability to advance in computing. And so as computing power has increased, so has too our ability to conduct these types of analyses. And that's sort of a throwback as well to many times where I've referenced Bayesian analyses as another form of analyses in these lecture series, how that was really a tool, that is a tool that it requires a large amount of computing power. And so that's available to us very easily now than it was 100 years ago because of computational advances. So surveys more broadly obtain lots of data, but more importantly, we can also have the computing power to analyze that data. And the cons are low compliance. If you administer a survey, you'll find that more often than not, people there's many surveys out there. People are being asked to complete surveys all the time, whether you're purchasing a product online or whether you've engaged in a service, or whether, say, you're in a university course and you're asked to provide feedback on your university experience. There's always surveys that people are asked to complete, and a challenge is always low compliance. And the challenge of low compliance is for a few reasons. One is, of course, you want to maximize your data, but you want to ensure that the evidence that you're receiving is representative of the population. So from what you see in your target sample, it maps onto the whole population. And if you have low compliance, it can be challenging to ensure that your data is representative, but not always. You could have a small amount of data and it's randomly selected and it could be representative, but it is a challenge with that. And you can also have skewed views that are from your survey. Maybe people who complete the survey are incentivized to do so. Maybe they feel passionately about the project or about the views that are asked, either positively or negatively. And so that is okay, but if you take that within the context of what does this mean in the broader scheme of these results, can you generalize to the population? That's where the gap is needed to critically analyze that question. And so the other con is that it's a reliance on self-report. We're asking people how they would rate themselves, how they believe their certain behaviors are that they engage in. And so fundamentally, if they have either little insight or they masquerade their results or aren't being honest, that isn't necessarily something that can be detected through the survey process. So those are probably the main cons of survey research. But you can see there's a lot of pros and it's advanced a lot of what we understand about the world around us through this research. So the self-administered surveys, they're cheaper. So we've talked about the cost efficiencies that are there. They suffer less from demand characteristics. When people are doing experiments, do they get a sense as to what's going on and maybe what you as a researcher are hoping to see as the results? And then they may be inclined to provide you with results that you're looking for. Surveys allow us to access a representative sample, So we have the access, but not necessarily do we obtain that representative sample. But these are the things to consider. They're anonymous, which is really important because it can allow us to ask questions about sensitive topics and ensure that perhaps the responses that are in relation to those topics are more authentic, particularly if you're talking about things, say, as drug use or anything that people may not want to associate their identity to, perhaps, or may not want others to know of. Maybe it's even just medication people are on. All of these points can lead to the advantages of having the anonymous part, but they suffer from non-response, and it's difficult to adjust for factors such as cultural differences and special needs. Non-response is probably one of the biggest challenges that you'll have when administering surveys. And so it's identifying how do you maximize that response rate as best you can. And we talk about that in the design characteristics. But it's Also, yeah, it's difficult to adjust for factors that um, cater to specific groups of people. And so we have to be conscious of this in the design of our research. And survey design is an art and a science, especially for enhancing compliance, especially for ensuring that you're tweaking and adjusting it to ensure that you're asking the questions in the best way possible to essentially ensure that you're measuring what you intend to measure. And in maximizing response rate through ways of designing the survey so that people find it easy to complete. If ever you get someone and they click on your link to complete the survey, and as soon as they do it, they find that it's too hard or too difficult or not too clunky, that's where you'll get that non-response. And so even things of having a progress bar to help motivate people, incentivize people if it's an online survey, or if it's a paper survey, having colored paper, all of these things can help. And I would argue when you think of survey design being an art and science, there's a relationship between artistry and science. They're not independent fields. One of my one of the people I admire is Leonardo da Vinci, not only as an artist but as a scientist and an engineer. Not many people know that he was fascinated about how things worked, how the human body worked, and he was well known for actually hiring people like grave robbers to go and rob graves, and he would have these cadavers, and he would um, sort of dissect them and be able to draw these beautifully anatomically precise drawings of the human anatomy and physiology structure. And this is really, and you'll see, hopefully you've seen the art of science in twofolds. One in terms of in terms of the images of graphs that we use and display data and how that can mislead, but also through the process of justifying your rationale for when you're using different techniques or assumptions and you're trying to justify that your approach is the way you're doing it. And sometimes it's out of our control. It's we're doing this research and this is the sample we have available to us, and we're proceeding with the analyses, but we're considering the results in light of these limitations. And that's really the piece that's there. And so that artistry in science, I hope that you have developed a bit of a love for, but also appreciation for, and are conscious of moving forward. So the types of questions that can be in survey research include objective versus subjective. So objective is where there's a verifiable true answer if you ask someone what their age is or how tall they are. Subjective is perspective of the respondent. If they subjectively state their levels of disorganizedness or engagement, these are all subjective. How they may feel may not map on to how others see them or what the other measures show. But it's from the perspective of the respondent. And then there's also open versus closed questions. So open is where you have an empty space for an answer, and closed questions is where you have a preset response options. And through the process, particularly for closed questions, when you're designing surveys, the important part is testing those surveys through pilot testing, because especially when you have preset response options, you don't want to be in a position where someone has a response and it doesn't fit into any of the categories that are listed on the survey, and so they find it challenging. This can be mitigated by having an open response where people can put in that information, you don't lose that information, but also through pilot testing, you can ensure that you're capturing as much as you can through those closed response questions. Now, level of measurement, this is one of the most important points that we discussed because it was the foundation for many things we discussed as the lecture series went on. We talked about how many analyses are contingent upon the types of measurement, level of measurement being used. We went through the different categories: nominal, having arbitrary numerical labels or categories, which could be in any order. There's no inherent order or ranking in the categories. So for example, what if I ask what pet do you own, and you say cat, dog, bird, other, then these are all nominal categories. Ordinal is ordered numeric labels where the intervals may not be equal. So for example, the order in which people have achieved scores in a course or in a test, they could be first, second, third, but the scores that they receive could be 99, 98, 97, and it could be 99, 70, 50. The ranking is preserved, but you can see the gap between those differences is not the same. So this is an ordinal variable rather than an interval or ratio. Interval is where you have ordered numeric labels and it's equal intervals. And then ratio is where there's a meaningful zero, such as something like weight or height. Now, interval, we talked about the controversies around Likert scale data and how for the purposes of this course, we focused on interval Likert scale data as interval level of measurement. But it's something to consider moving forward in your careers as whether that is necessarily the case, or is it better reflecting ordinal data, particularly when the scale is low in terms of its distribution. So it's a 1 to 4 scale or 1 to 5. And then we talked about sampling. So sampling requires an understanding of your target population, sampling frame, and sample. And we can use probability sampling methods, which are random, including simple, systematic, or stratified. Or we can use non-probability sampling, including convenience, purposive, and snowball sampling. And they each have their strengths and limitations. With non-probability sampling, often at times it might be easier to recruit rather than engaging in probabilities for having a larger sample size. But then again, with probability, we're able to have a random sample, so we're able to say that the results that we see are likely reflective of the true population that we're investigating. Whereas in non-probability sampling, that is not necessarily the case. But again, we talked about the pros and cons of this. For example, there are certain maybe research topics which may require this snowball type sampling technique where you ask someone and they ask someone else about and they refer someone else for the study. For example, if you're trying to go to a very remote community and you don't really have access into that community, if you have access to one person, maybe they refer others into the study for the purposes of collecting that data. And so sampling techniques each have a, this again comes back to that point of having a considered thought as to at every step, why are we doing what we're doing, and what is the purpose of the focus of the study? How does our sampling technique allow us to obtain the target population and influence our conclusions that we make as a result of the sampling method that we've chosen? And then we talked about sampling biases. So the sample doesn't represent the target population. This is often at times when you read papers, you'll see that perhaps the population that they sample from, it could be something like a typical one in psychology is of university students. And so they sample from university students, but then, however, they make claims that generalize beyond the scope of the population that they've sampled from. And the question is, well, does that sample actually reflect the target population? Or is it maybe a skewed population? For example, those who are able to attend university and study, and maybe that reflects age range brackets or differences in demographics or other features as well. And then we also talked about non-sampling biases. So the measurement tool issues for reliability and validity, and these include response biases in terms of how respondents are likely to provide their information, and the acquiescence bias and order effects, and how the responses that participants provide could vary as a function of if they're likely to just agree with what's there, or perhaps if the order of questions can actually influence the response that people provide, then that could be a bias within a challenge within the findings of your study. Demand characteristics, which we touched on, self-serving bias and social desirability, and the Hawthorne effect. The Hawthorne effect being where people may act differently when they feel like they're being observed versus where they're not being observed or known to be observed. And so we talked all about all these different types of biases and the contributions that they may have to our results and findings. And so lecture 3, we talked all about descriptives and graphing. What is the central tendency, frequencies, percentages, mode, median, and mean, and we saw how these can vary as a function of whether the data is positively skewed or negatively skewed. And then we focused on variability around these measures, so the minimum, maximum, range, quartiles, and then also standard deviation variance for normally distributed data. And when you look at a paper and you look at the table 1, which typically includes the demographics and the key measures of the variables that are of interest, you'll see that the data that's there should reflect the author's investigation of these univariate descriptive statistics. And so if the data is skewed, then it should be reporting the median and interquartile range. And then if it's normally distributed, they can report the mean and standard deviation. And the reason for this is we know that, say, the mean can be pulled towards the extreme values or the tail of a distribution, particularly when it's skewed. It can be pulled towards the tail. And so it's important to ensure that the measures used in the descriptives are actually representing what the distribution is of that variable. And so central tendency and variability were key components that we looked at. And then we also focused on how we graph the data. So we have nominal and ordinal data, which can be graphed through bar graphs or pie charts. And then we have interval and ratio data, which is graphed through histograms, stem and leaf plot, and box plots. And we also focused on the fact that this can be misappropriated or people could be led to or misled as a function of poorly graphed data, either intentionally or unintentionally. The nature of which how data is portrayed in visuals, whether the y-axis is shrunk to focus, to magnify the effects that are perceived to be there. All of these things can negatively impact the ways in which science is understood and communicated to the public. And so when we are communicating science, it's important that these skills of critical thinking when it comes to looking at the data and how it's visually described, because people naturally focus on the visuals, it's important that we understand how to do this in a way that's ethical and transparent for everyone. And so these are the key features of graphing with any sort of data, but univariate data. And then we went to lecture 4, where we're talking about correlations, and we said that the whole world is made of covariations, and the difference of, we looked at the relationship between covariation, correlation, and how largely it's as one variable moves up, then the other variable moves up, and so they're moving in the same way. And so covariations are really the building blocks of more complex multivariate relationships. And we said, well, the challenge with covariation is that both of the measures have to be on the same scale. But we're able to address this challenge with a sense with using correlation, which is the standardized measure of the covariance. So the extent to which two phenomena correlate, and it allows us to look at variables that aren't necessarily on the same measurement scale. So then we can start saying, well, what is the relationship between height and weight? And then you can get a sense of the relationships that are there. And we focused on how correlation does not prove causation, however, noting that when things are causally related, they will be highly correlated. But the fact of the matter is that just because things are highly correlated does not mean that there's a causal relationship there, or irrespective of the strength of the correlation in itself is not enough to prove causation. So how do we prove causation? We can look at time-varying effects. If you administer something and then you wait and you see what the effects are after, then we have sort of a causal link in the pathway there. But fundamentally in scientific research, through randomized controlled trials, we randomly allocate people to groups, administer a drug, and we see what the effects are, and allows us to mitigate the influence of variables that are typically influenced in observational studies but not in randomized controlled trials, due to the random allocation of participants and treatments across groups. So that is correlation and covariation, and it is and has been one of the building blocks to all of the complex analyses in terms of the assumptions, in terms of the understanding of how factors are, there's correlations amongst the variables or the items that are there. And correlation is really the building block of many of these more complex analyses. And so the purpose of correlation is to investigate what is the relationship, association, shared variance, or correlation between two variables. So these are the sort of questions we're asking when we're doing correlations. And then to what extent do two variables covary, depend on one another, and explain one another. So that's really the core focus of correlations. We're trying to get a sense of how are these two variables that we're interested in related to one another. And then in a more practical sense, then we go to the step of thinking about causal language. So if I was to make changes in one variable, does that cause changes in the another other variable, or is it bidirectional because it's a correlation analysis? And what are we? And in some ways, we're not able to test that causal mechanism, but in many cases we can. So it's important to think in these ways. And in the types of correlations, we focused as well on whether it was, again, coming back to the level of measurement. So if it's nominal by nominal, we use chi-square with phi or Cramer's V for effect size. If it's ordinal by ordinal, we use Spearman's rank or Kendall's tau. And then we have dichotomous by interval ratio was the point by serial correlation. And then interval or ratio by interval ratio allowed us to use Pearson's product moment or Pearson's R correlation. So all of these were ways in identifying the type of correlation to use based on the level of measurement or data that you have. And so the steps we take is choose a type of correlation and graph based on the level of measurement. We check our assumptions, for example, linearity and outliers, and report effect sizes. That's critical. The direction and significance. So those are really three key components that need to always be reported together. So what is the effect size? What is the direction of the effect? And what are the whether or not it's statistically significant? And the percentage of shared variation. And again, be wary of limitations. For example, that correlation does not equal causation. Just because there's a correlation doesn't mean they're causally related factors. We need to do further research to investigate it through different mechanisms to be able to determine causality. Excellent. And in saying that, let's take a break there. And when we come back, we'll talk all about exploratory factor analysis. So have a tea, stretch your legs, and I'll see you guys very soon.